So in this practice SAT problem, they say that the perimeter of an equilateral triangle is 624 centimeters. The height of the triangle is k times square root of 3 centimeters. They tell us that k is a constant. What is the value of k? So I drew my equilateral triangle, drew my height in. Keep in mind, a height on a triangle has to be an altitude to what you're considering the base. So it has to intersect the base at a right angle. When I just isolate the right-hand half of this triangle, I can actually begin to label some values. I know that the perimeter of the triangle is the distance clear around the outside. And because it's equilateral, I know that all three of these measures on the triangle's outer edge will be the same. So if you take 624 and you divide by 3, you get 208. So 208 centimeters here, 208 centimeters here, 208 centimeters here. Now, because of the symmetry involved with an equilateral triangle, when I draw this altitude, when I draw this height, I know that this 208 centimeters across the bottom is going to get bisected by that altitude. So that ends up being 104 centimeters. Now they tell me that the height, this vertical dimension here, is k times square root of 3. Now if you take a look at this triangle here, which clearly is a right triangle, you can apply the Pythagorean theorem to it and then solve for k. So that's the work that I've done over in the right-hand corner here. So that's one way to figure out that k needs to equal 104. Another way would be if you have your 30, 60, 90 right triangle ratios. This is a 30, 60, 90 triangle. Clearly we have a 90-degree angle here. The original angles in the equilateral triangle all measured 60 degrees, so that's a 60-degree angle here, and that only leaves 30 degrees of the 180 total for the triangle remaining for this upper angle. You can use the 30, 60, 90 ratios to realize that the biggest side on that 30, 60, 90 ratio is going to be the base measure times 2. The smallest side is going to be the base measure times 1, and then the middle side is going to be the base measure, which in this case is 104, times square root of 3. So Pythagorean theorem works even if it's technically not a 30, 60, 90 right triangle. The 30, 60, 90 ratios work because that is the type of triangle that we're looking at here.